All right, so today's lesson we're going to be focusing on something called correlation coefficient. We talked about this a little bit last class, and I want to continue this discussion. So by the end of class, you should be able to describe the direction and strength of a scatter plot using the correlation coefficient. So last class we looked at the class data to determine who the best guesser was. And the way we figured out the class's best guesser is by looking at something called the correlation coefficient. So to determine the best guesser, we used a measurement called correlation coefficient. And if you recall from the other class, the symbol for the correlation coefficient was R. So correlation coefficient is helpful for two reasons. One, it measures the direction of the scatter plot, and it also measures the strength. So that R value that Desmos gives us tells us two things about the scatter plot. So let's talk about direction first. There's three possible directions. Right? If you have a positive correlation coefficient, that means your scatter plot is moving in the positive direction. So something like this. All right, that means that it's moving generally in a positive slope. So as x increases, the y also tends to increase. So as the x values are going up, you can see that the y values are also going up. So that's one possible correlation. You could also have a negative correlation. So as you can imagine, that means our scatter plot is going something like this. And you can see the general trend is it's going down. So that means that as x increases, the y values tend to decrease. Right, because you can see that as x is getting bigger, the y values tend to get smaller and smaller. The last type of direction we call no correlation, and that's when you have a scatter plot that's generally all over the place. And in a situation like that, we say that there is no relationship between the two variables. Okay, so that's direction. All right, so when we see that R value in Desmos, the sign in the front of the R value tells us whether it's positive correlation, whether it's going up, whether it's a negative correlation. No correlation means we would be looking at a scatter plot that's all over the place like this. The other value it gives us is strength. So we have a number line from -1 to 1. Correlation coefficient will always be between these numbers. It will never go past -1 and it will never go past +1. So if you have a correlation coefficient that's between -0.25 and 0.25, we say that this relationship is weak. Because right here at 0 means that there is no relationship. So that means between here and here and here and here, we consider that a weak relationship. Next, from about here to about here, we say that this is a moderate relationship. So kind of strong. And finally, from this piece to this piece, this is what we call a strong relationship. And what this tells us is how close it is to making a straight line. So if you see a scatter plot that's all over the place, then we would expect that its correlation coefficient to be somewhere in this range of values. All right, we know that if we have a perfect straight line, it's going to be positive 1, or if it's going in the negative direction, it's going to be negative 1. So let's take a look at some examples. So here we have a bunch of different scatter plots. Let's start with our negative. So if our correlation coefficient is negative 0.99, that means that we know that this is going to be going down. And since this is really, really strong, we're looking for something going down that's almost a perfectly straight line. So that means it must be this one. Next we have negative 0.6. So this negative is telling us that it is going down, and 0.6 is moderate, so we're looking for something that's really close, or pretty close to making a straight line. So probably this one. See, it's going down, it's negative, it's not really as fully formed as this one, but we can tell it's making a straight line. Alright, and next we have negative 0.2, so we know that it's going down again. 0.2 is pretty weak, so I would narrow it down to this one and this one. And then when I look at which one is more closely forming a line, it looks like it might be this one. So next we have R of 0. That means that there is no relationship. There can't even tell what kind of form it is. It's all over the place, so I would go with this one. Next, 0.5 means it's going up. And 0.5 is moderate, so it's kind of making a straight line. You can see the points are close to making a line, so probably this one. And our last one is also going up. You can tell that it's pretty close to forming a straight line. So something to be careful about is the fact that correlation does not mean causation. Just because there's a relationship between two variables doesn't mean that one causes the other. The only way you can prove causation is by doing an experiment. This is the only way that we can prove that something causes something else to happen. Okay, so now that we have a general understanding of how correlation coefficient works, let's look at a couple examples. So in this one, we're comparing years of education to income. So how many years someone had schooling and what their income was. So the first thing we want to do is we want to find the correlation coefficient. And if you remember, what we did was we went to Desmos, we typed this into a table, and then we did y1 squiggly mx1 plus b. So let's do that real fast. So we go to a table, we enter it in, 19, Once our data is in, I go to this little corner where I say zoom fit, and you can see that it automatically zooms out for you. So we're looking for correlation coefficient. So in the next line, I type y1 tilde mx1 plus b. You can see down here where it says R that the correlation coefficient is 0.5656. Okay, so what does that mean? Well, it's positive because the correlation coefficient is positive. So that means as years of education increases, income tends to increase as well. See how I wrote tends? I wrote that because it's not necessarily true. Sometimes there are outliers in the data set. And what strength is this relationship? Well, if I go back to my scale, 0.565 is right here, so we're saying this is moderate. So it's a pretty strong relationship. It does seem that one might somehow be related to the other. It does not mean that one causes the other. We would have to do an experiment. All we know is that years of education might have something to do with income. All right, our last example, we want to see if there's a relationship between how many siblings you have and the number of hours of sleep you get. So to see this relationship, the next thing I'm going to do is go back to Desmos, make a new table, and find out what the correlation coefficient is. Alright, let's see what this looks like. So y1 mx1 plus b. The correlation is 0.2449. Actually, I think I made a edit problem. Alright, so 0.2449. 0.2449. Alright, again, this is positive. Because this is positive, that means that as number of siblings increases, hours of sleep tends to increase. What is the relationship? Well, 0.2449 is kind of on the borderline between weak and moderate, but it is falling right about here, so I'm going to say that that is a weak relationship. Doesn't seem to be a lot of evidence between both of those variables. So at this point, what I'd like you to do is I'd like you to try these two practice problems right here underneath. When you're done, just check them in with Amy, make sure it's completed correctly, and then you can move on to your next assignment.